Okay, so today we're going to look at some 3D problems and trigonometry, and we're going to use some various diagrams to try and help us. So let's take a look at the first problem we have here. We're given a cube with all edges of length 4. So that means it's 4 centimeters by 4 by 4 by 4 by 4. Every distance is 4. And we can see that also on the axis that is there. And we want to find the length of AC, which is down along the bottom, and then the diagonal across, and then the angle at the end. And to maybe get a better sense of what this box looks like and how all of these things are related, let's take a look at the box in 3D. Here is the box, and if I rotate it, I can see various things here. And I'm trying to get a look at AC here. And if I think about AC, oh, come here. AC is on the bottom of that box. And what I see for AC is I can see that I get a triangle in the bottom of the box, and this is a right angled triangle that I can maybe see that's right angle here just by the fact that it's a cube. And so I can use the fact that it's a right triangle to find AC, because if I redraw this box, if I look at the bottom here, this bottom triangle here, A, B, C, if I redraw that, let's say A, C, here we go, here's A, here's C at the bottom, and here's B. This is 4 because it's the edge is all 4, and this is also 4. And from that, what I can tell is that if I want to find that missing length, I can use Pythagorean theorem. And so AC squared, which is my hypotenuse, is equal to 4 squared plus 4 squared, which is going to be a 16 plus 16, which is 32. So AC squared is 32. So AC is equal to the square root of 32. Now, if we simplify this radical, just to, this is 16 times 2, and then I choose a perfect square, which is 4 root 2 centimeters. Or I could go to my calculator and get approximately the square root of 32 is 5.66 centimeters, and that's to 3 significant figures. I'm going to take this value though, and I'm going to store it, because when I do later calculations, I want to use all the decimals. So I'm going to store that answer into alpha A. And so now A, whenever I go to A, it has this value here, which is AC. All right, so that's A part done, find length of AC. Now BC says find that diagonal across HC, across about HC. So if I look here carefully, I can see that I have another triangle going through the center of the box here, which is also a right angle. If you're not sure, if I go over here, I can see that that is going through the center of the box, and it is also a right triangle here as well, going HCA, where A is the right triangle. And so using that idea, I'm going to redraw my triangle down here. Here's, and then this is A, what's a right triangle? This is H, and I know that height is 4, and this is C, and this height is square root 32, which is the 5.6. And I'm looking for HC. I also know that this angle here is alpha. So I'm dealing with this triangle now, and the questions ask me to find HC. Well, again, Pythagorean theorem works nice, so HC squared is equal to 4 squared plus square root of 32 squared, which is then 16 plus 32, which then works out to 48 is AC, or not AC, but rather HC. HC squared, which then HC is the square root of 48, which I know is 16 times 3, which is 4 root 3, or approximately, I can go 4 square root 3 and get 6.93 centimeters to 3 significant figures. And so now I have HC. The last question has me find the angle. In order to find the angle alpha here, I have 4 and I have square root 32. 2 alpha, and I'll switch over to purple. 2 alpha, I know this is the opposite and this is the adjacent side. And so opposite and adjacent is tangent alpha is equal to the opposite side divided by the adjacent side. And so if I want to find alpha, I go to my calculator and I go second tangent, because this will find me the angle, and it'll be 4 divided by the square root of 32. And enter, and my angle is 35.3 degrees approximately. And so in this particular 3D problem, we have to visualize the triangles that are in the box, the right triangles, and then use Pythagorean theorem and trigonometry to find what's missing.